So mighty fine good morning, everybody. My name is Cale Harbor. I'm the product manager here at Advanced Control Solutions. Recognize a couple names on the attendee list of having been to some of our webinars before. Thank you for coming back. We are hosting this morning a more technical topic, and we have one of our automation specialists, Mr. Max Smith, who's going to be walking us through the incorporation of the LMI GoCater 3D sensor with a UR robot to do 3D analysis and pick and place routines. So for those of you who have attended a couple of our webinars already, some of them have been technical, some have been more informational. This is going to be more of a technical step-by-step. We're actually going to create the programs and perform the calibrations live. And during the course of it, if everyone would stay muted just to be able to cut down on background noise. However, I'm going to be moderating and watching the chat room. Should any questions come up, any additional details we need to be able to provide to you while Max is presenting, please post it to the chat room. I'll be watching it and feeding those questions to Max. Either if it's important enough to do while he has it on the screen, I'll interrupt him. If not, I'm going to hold him until a natural break in the presentation, and we will get those answered accordingly. Also, we're going to be reaching out to you with the a follow-up email with this after we get done, with the links to be able to find the video when we get finished with it. And as always, as Max pointed out, you can always reach us on our website at the info email address that he showed a moment ago. We'll show that again before the end. So Max, I think that's all the housekeeping issues that we've got right now. Are you ready to educate us?
Yes, we are. Again, my name is Max Smith. I work out of the Nashville office for ACS. Robotics specialist is my title. Work a lot with our robotics line. So UR, MIR, Epson, and some of our sensors. I do a little bit of Cognex and a little bit of the LMI sensors that we will be showing today. Basic overview, yes, UR likes to work with other third-party vendors to integrate their software into their control, into the UR controller, so you don't have to have an external box and more wires run than necessary. For this one, you still need a few extra things, but let's talk about the housekeeping of setup. So today I'm going to be using a 2330 profiler. That is part of the new UR. Let me step back just a little bit. The software I'm running for this is in beta. So as this is technical, I do want to show you how it works, and it is working. It still isn't fully released. They want to work out some bugs, but should be released within the next month or two, I believe. Now back to that, we're using a profiler now. So the profiler they like because you can scan, and this way you'll be able to get a long field of view. So for my demonstration today, I'm keeping it to like 150 millimeters, but you can expand this to, 10,000. I'm not sure the upper limit yet, but they've been, touting this as you can scan like a full flushing gap on like a car door or something like that. So, we're testing it, and the idea is to show you guys the possibilities out there, and we want to, bring in projects and see if it'll work, and let's keep going. So yes, I'm running a 2330 sensor here. I've got a 2-finger Robotique gripper and my UR5E arm. This does work on any of the robots, but this is what I've got in the office with me today. Some more general housekeeping notes. Oh, there goes something. I'll pick that in a second. A mounting plate. So this just gets me a 3D printed mounting plate for my sensor and my gripper. The part that I'll be working with today, kept it simple. This is just a dual charging block, keeping it simple. If you notice on the screen, I've taped off the 150 just to help me keep my bearings straight. And I've got a little Allen key posted in there. That's not something I'll be scanning. It's just so I can get some angle and show you some angle and rotation change that it'll pick up. And one of the most important pieces here, so you do have to calibrate the GoCater sensor to the robot world coordinates. That's the magic of the LMI cap, and mostly to get that done, you'll need something that's called a ball bar calibrator. This I just made myself. I went and got a couple of shop beads, and I put a paper clip in between them. They do have a very specific, one from LMI if you want to get the, in your actual process, the one with the, pre-built, very accurate values, you can do that. But this does work if you just want to have it tested.
Hey, Max.
So,
Max, the white balls against your white shirt didn't stand out well. Would you set it on the blue tape down on your tabletop? Awesome. Thank you.
Thanks for helping me out there, Kale. Okay, so that's some general housekeeping. I'm going to share this other screen for a second as well. This is the LMI page. So if you need to look at the sensors and the field of views that we're working with, you can always go to LMI and pick them up. Again, I'm working with the 2330. So the heights that I'm picking from my robot to scan from, they're all because of, the working distance and field of view that this particular sensor gives me. You can get larger field of views on some of these other guys if you need a larger part or smaller parts as well. The LMI sensor is a web-based application, so it's all typed in with a IP address, and it goes to that sensor. Everything is saved on the unit. So here I've got my setup on my 2330. And so now I have a pre-built job loaded onto my teach pendant. What I'm going to do first for you guys is show you the job running, just so you get an idea of what it can do. And then I'm going to go through the steps of how I built it. So here is my teach pendant with my job. Here's the GoCater scanning table. I've already scanned something this morning, so you'll have to excuse that being in there. But when I press play on the teach pendant, you're going to see the thing running. I'd like to show you the scan as well. So everything is controlled from the teach pendant once everything's running. And I've gotten an error. Could not reach the pose.
While Max is working on that, the software that he's showing on the screen that actually shows the thermal map of the 3D height alignment does not have to be running at the same time of this. As Max said, everything is controlled from the teach pendant. We're using this software so that you can see what the scanner is able to see as far as the data coming back in. So this software exists on the LMI GoCater. It is a web-based interface used for programming that we're going to be getting into in more detail here in a minute. So by logging onto the IP address of the sensor, you're able to get to the programming environment. So there's no extra software to install. But as Max said, once you have the system calibrated and your job done, everything is run from the URCap pendant.
So excuse my problems there. I actually loaded a blank job, so it wasn't sending over any data because there was no tools.
Well, you know the rule of thumb, Max. If anything's going to go wrong, it's going to go wrong in the middle of a customer presentation.
That's correct. So here, again, this is a simple pick and place right here. I'm not doing any actual tools yet, but you can also put tools in with your LMI job to make a decision on, is this a good one or a bad one to go to those bins. So I'm going to make this full screen. You can see down here, I've just got a couple of random placement generators, but once the part goes there, it goes to a beginning scan height, runs over the part according to the distance I chose, and can handle some angular orientation there. Now, I would slow it down for you, but the one caveat of this is the speed at which you calibrate does need to be the speed at which you scan, so the calibration is valid because it's not using an encoder, it's using a time base. So let's let that run once or twice more. But what we're generally doing there is getting a scan. And if you see here, the coordinate that's being sent over is that position right there. So as we get a scan, it should update. You can see the coordinate system is moving with it and tracking within the field of view. Okay, so now we're going to pause here and I'm going to build some blank jobs and start from the beginning and show you how it works real quick.
While Max is getting that changed over, I just want to remind everybody that if you have parts or an application that you would like us to test, you can send those parts to us. Just shoot me a message in the chat window and I'll be happy to send you the address and the information to get that in. What we can do is then be able to run the part, set up the test sequence, and either tie in with a video conference or a recording of us actually performing this application with a live sensor and robot.
So to start with here, I'm going to say I'm making a few assumptions. I'm going to say that you guys have used a UR before, so you kind of know where some of the buttons are. Of course, if you don't, we can't explain that stuff, just not during this presentation. I'm going to assume that you know how to make a TCP or a tool center point. That is where the part would be grabbed by the gripper. And I'm familiar a little bit with the go-caters as well. Again, you don't have to be. I'm going to show you these buttons, and if you need further explanation, please get in contact with us. That's what we're here for. So on my teach pendant, I'm going to create a new program. Let's see if I can make this focus really fast. I like that a little bit better. So I've got a blank program here. I'm not going to loop programs forever because we're going to do a calibration, so I don't want it to run multiple times. Again, I am assuming you know how to make a TCP. And a note here, you do need to make your TCP before calibrating the sensors. So those values are brought in and accounted for. So under the URCap page, if this was brand new, you wouldn't be connected yet. So the LMI Gocator and the robot and your computer should be on the same network. And then it will auto find this if it is on the same network. You can connect. And then there's the second button called Setup Job. And this is where the magic starts for their LMI cap. So when you click Setup Job, it says it's going to remove the trigger sensors and settings from the Gocator. Yes. And what this is doing is building a job onto the Gocator. It's a pre-built job, but it's loading it onto the Gocator, and that will allow you to calibrate. So for now, I'll go back to the program and drop in this URCap that is called Gocator Calibrate. So we'll be picking our sensor. Again, that will auto find it as long as it's on the same network. I'm going to load or point to the program called Go Robot Calib. And this will always be the job name as it's created by the sensor when you click that setup job. little bit faster with my finger. Again, so this is where I was saying you can pick whatever surface length that you need. So for my ball bar calibrator, it's only about 40 millimeters, 150 is fine. Again, this is for, if you have a sensor that's larger or smaller than the 2330, and of course the calibrator size. Here you can change speed and acceleration. I'm going to leave them at default for now. The only note is whatever one you have to, or whatever you calibrate at here for speed and acceleration should be the one you use in your job as well. So that's all you need on the teach pendant to do the calibration. This GoCater Calibrate will run the GoCater, and you'll see this momentarily, in about 8 different poses. And those poses will have a slightly different starting position for the scan. So, if it's straight on the first time, it might add a 15-degree orientation to the next scan, and then a negative 15-degree to the next one. And you'll see this. So I'm going to switch over to the screen, but I'm also going to pull up the LMI programming page. So just to note, you see here now that this is test unsaved. What I'm going to do is refresh the page real quick, and that setup job button that we clicked back in the teach pendant built and loaded this Go Robot Calib job in there. And all of it is right now is the surface bar ball tool. And again, I showed you the surface ball bar earlier. That's what you calibrate to, and this tool is made by them to do all that for you. So if I scroll down a little bit, you'll see all these values here, and it's going to build a calibration matrix that it sends over to the URRobot that will make the LMI sensor data be robot world coordinates and be able to drive the robot to it. Just to double check everything, I went to the output page, and you see that these are all checked. They do need to be checked to send those values over. Well, it's supposed to shrink that, but let's just do for now. So what I'm doing is I'm putting the little ball bar calibrator within the field of view. Again, that's why I taped it off, just so I knew what it was. It's not that hard to do, but it just makes it easier. And using just this GoCater Calibrate node, I'm going to press the play button here in a second, and you'll see it scanning. And I'll leave this up so we can see it. Don't know why I'm having such a problem with this sizing right. There we go. So I'm pressing play on the teach pendant. And the robot's moving. And we're getting the scan of this. Now you can see the values are coming in. What we want is a valid distance 3D. If you get an invalid, that means it's not scanning right. But the program will also let you know if it doesn't get enough valid scan positions to do the calibration. So you see the robot stopped running. That is the magic of the cap. That's what the cap is giving you, that calibration to real world coordinates of the robot. You can see it's not moving over here anymore. I'm going to flip this over. And a way to check that you got a good calibration is this GoCater Connect. I'm just showing you this so we know that we have it, but you can see that there are values in this loaded calibration matrix. If you didn't get a good calibration, that would be blank. So continuing on, I'm going to create. So now I'm just going to stop there for a second. Now we do have a calibration within the teach pendant that was sent over from the GoCater. Now we can start to build a job. So I'm going to start fresh program here. Discard these changes. I'm going to unselect program loops forever. Depending on how you build your program at the end, you might want that selected, but just for creating your job to scan the part, you want to just let it run once. So I'm also going to add before start. And this is where you would use your GoCater Connect. So as soon as you start your program, you connect to your GoCater. You tell it to load that calibration matrix that we got in the calibrate step. The first thing I'm going to do is add in a move. And the robot goes back to the first position after calibrating. So I think this is a good scan point for this particular sensor, or scan height for this particular sensor's field of view and working distance. One thing I will say, I'm going to ignore my active TPC for this TCP for this particular step, because that's where the GoCater needs to be scanned. I will use another URCap called the GoCater scan. And this is where, depending on what your part is, you would be able to select how far you want it to go. Again, just for this example, 150 is good for my field of view, but if you were scanning a larger part, you could do, whichever size you want. So just to give you guys an idea what I'm doing, switch back to my other camera. So now I'm putting the part that I want to scan in the field of view, because you have to have it on your GoCater screen scanned into build tools. Right now I still have my ball bar calibrator in there. So with this program right here, that's how you would get the GoCater to scan once. And pressing play on my Teach Bendit. Now the GoCater scans and we have our part to program off of here. So I'm going to come into the GoCater and show you how to get the coordinate stream running into the GoCater, or into the UR, sorry. Go ahead and delete that tool now. Technically, I'm going to create a new job. So whenever I save it, I'm not saving over that calibration job. I'll call this test 2. So what tool we're going to need to get to eventually will be the feature robot pose. So I'm going to add him so you can see what I'm trying to get to. The XYZ, RX, RY, RZ, or your XYZ and your rotational data, whichever way you want to call it, is what we want to send over to the UR. But to get that, we're going to have to give it some data. So we need to get a point, a plane, and a Z-angle line. And to do that for this specific part, now depending on your part, you would build different tools. But for this specific part, I know that I can use a surface bounding box, a surface position, and a surface plane tool to get the parameters over to that robot feature pose, feature robot pose. This is also a new look in the beta software. This will be coming for everyone once it's released. If you've used the GoCater, it's always typically been this. They're giving us a little better look, or they're trying this out in the new software, by the way. So the surface bounding box. This, I'm going to make almost the whole field of view, because this will help us track our part and the tools within the part, within the field of view. So if you see right now, the surface bounding box is way too big. We're picking up the nest or the surface there. We don't want that. So we'll bring him up just a little bit. Now we're tracking our part pretty well. We may want to add a surface filter depending on your part to kind of get rid of some of this so it shrinks the box size. But instead of using that, I'm going to actually use the surface position to get a better Z height, since that box is a little large. You know, you may need something tighter with your Pacific part. But I do have a surface bounding box. I'm going to turn on a couple of things: the rotation and the box axis line. This will help us get our rotational data later on. I'll show you where we're going to tie that in just a minute. So now we got that. I want to turn my X and my Y on because another tool will use this. So that's good for the surface bounding box. Now the surface position, I'm going to use this one because I like it better than the surface bounding box to get my XY coordinate to be more dead in the middle of this and not with the Z height. So bring him up a little bit off the underneath the surface plane or the nest. And then also turn this to a median. Again, this is specific for the part that I'm doing, but it doesn't have to be done this way. It would, your tools will change a little bit depending on what you're trying to get at. But you can see now, instead of having the surface bounding box with this, you know, sliver of height, this one gets directly on the plane and in the center of my part. So for me, that's just what I'm using, but I do need to anchor it. And this is what the surface bounding box will get us. So as we move to the field of view, this tool will track. So now I'm anchored to the surface bounding box, X and Y. And then our surface plane tool will get us the angle of which the part is. So right here, it's pretty flat, but you can still see that this blue plane that it's built is tracking with the angle of your part surface. I do need to anchor him again. Now he'll move to the field of view with the part. And we'll go down to the feature robot pose. So now the reason why I built these three tools is to get this for the feature robot pose tool. So right now you see it's invalid. It's not getting good data. Once I tell it to look in the surface position point for my XYZ and the plane and the box axis line from the surface bounding box, now I get an XYZ. Now for this part, since it's pretty symmetrical, if you needed to have the robot gripper come in at a different angle, all we would do is do a pose add in the programming of the robot. You could say go 90 or 180, depending on how you wanted your fingertips to come in. Maybe your cabling is a problem, but that's pretty simple. So now you can see that this coordinate is good. I can send the robot to this coordinate and you should be able to pick your part. Now, I'm not doing any measurements or anything right now. Again, we could do that within the GoCater as well to make decisions as it scans in real time. Hey, it scanned and the width measurement was good or the length measurement was good, so go to the good bin. Or if it wasn't, go to the bad bin. Before I leave the screen, I will do this. Again, I don't expect y'all to know this yet, but this is part of the way it works. I'm going to make sure we send over the XYZ, RX, RY, RZ. And I'm also going to pick an ID number. For me, I've been working with 180, but all you need to be is have 6 consecutive digits open. So for me, it's going to be 180 to 185, but it could be any arbitrary number as long as you have 6 digits available that are consecutive.
Hey, Max, is the 180 just a personal choice, or is there a requirement you start at 180?
It is just a personal choice for me.
What's the range that you can choose from?
I don't know how high it is, but I've also done one starting at 200. I think as long as, I think you can send over 56 different things from the GoCater over the Ethernet. So as long as you're not sending over more than 56 outputs, I think you're okay. I think you can really arbitrarily select anything there as far as your consecutive digits, but I'll have to confirm with Mike at LMI.
All right.
I haven't had that question come up.
Okay, thanks, Max.
So over here in the outputs, the way to double check everything, again, I've selected from 180 to 185. They just need to be consecutive. And then of course, you do need to highlight them if they're not highlighted, because that means it's outputting it or not. So this is a fully built job to send over the feature robot pose. So I'm going to go back to our teach pendant and show you how to receive that information. So this job frame is still okay. You just have to add to it. So coming in, once we get a scan, now we can do something called a GoCater receive. Once we put that in there, you can see we get some information here. This variable name is just where you're going to store the coordinates. For me, I'm just going to call it on the wrong keyboard. I'm just going to call it coord. You could call it coordinate. You could call it point. It's just the variable name that you're going to store the information in. So here's where that ID comes into play. If it would have been a 100, I could have just said 100 to 105. For me, it's 180 is where it starts. You don't have to specify the end. It knows you're going to look from 180 to 185. So the measurement type, for us, I did the most complex part, which would be the full 6-digit coordinate stream. You could do just a single 3D measurement if that's all you need, or if your part doesn't have any angular rotation with the way your setup is, you could just do an XYZ coordinate. It's more like 2D. I mean, of course, that stuff's in there, but for us, we're going to use the full 3D string, and that makes this a pose. And then I'm actually going to select this flip around X. I think they're working on this because there should always just be selected. The flip around X means instead of the robot trying to drive to the point from underneath the part, it'll come to the part from on top. Maybe your process needs you to come from underneath, so it's a good option to have, I suppose. But now I have this GoCater receive in there, so now we're going to get that coordinate stream. I'm going to play this once before I move on. You can see here under our variables, right now there's nothing called coordinate or coord created. But once I run this one time, and get a scan, now you can see I have this coord created, and that is in robot coordinates, the point that was received from the GoCater. Again, the calibration matrix here in the GoCater connect step is how that gets converted over. And also by select the screen, you can see now that that part got scanned. That's the coordinate that got sent over as well. Okay, so I'm going to finish creating the robot job here. So now that I have a GoCater receive, what I'm going to do, I'm going to add in a move. I'm going to call it, this is a safe approach. I'm adding this because it's, you always want to come above your part so you don't like run into the wall or scrape on the top of it or something. Calling him safe approach. I'm just going to drive the robot up in the Z height. Keep it simple for now. It's just a way to stay off from the part from scraping it. In this particular step, we also are actually using the active TCP. That's good. And then I'll add another move in. And this move is going to be variable. And the variable position is where we store the data, coordinate. I now have a working job here. Obviously, you're going to have more steps added in for your process, but this is a fully working job. So I'm going to come back, play the robot from the beginning. And for you guys, I want to show you it running. So now parts here. I'm going to go ahead and throw it up on this Allen key, so it has some angular rotation to it. But just press and play on the teach pendant now. So you can see that the robot has oriented itself to the part, even with the angular rotation there. And it's right here. Since I picked a symmetrical part, test part, that's the reason why. You know, you're not sure which way your orientation is going to be. All you have to do is simply oppose add to get that 180 or 90 degree if you wanted it. So the part's there again. That's basically it in a nutshell. Of course, there are some caveats and some other steps to it. But this is what we wanted to show you. I'm going to load my other job.
While Max is loading that, I'm going to take care of a question that came in to me. The question was, how can we get additional training for the UR and the LMI itself? Because as Max said at the beginning of this, we're assuming a certain basic knowledge of these products. As far as the UR itself goes, there's several options you can go to. When we come out of the current virus crisis that we're in, ACS does host a series of both one-day free workshops, as well as we're a certified training center for the full UR core class that covers the UR robot. In the meantime, while we're in the situation we're in, there are other webinars that we're going to be doing that are going to cover basic programming and basic command structures. So please stay tuned for the webinar series. The third option you can do is if you go to the Universal Robots website, they have an excellent online academy that goes through a multi-step process that goes over the basics of how to turn on the robot, teach the TCP, the basic movement commands, and the command structure that goes with it. So I would highly recommend doing the online academy as a great starting point to get familiar with the UR world if you have not worked in it so far. For LMI, we are in the process of right now of our staff at ACS becoming certified to teach the training class for the new software once it becomes fully released. So we are ramping up to be able to hold the LMI training classes local. So learning how a bounding box works, how the different commands works, the surface plane, the filters, the exposure times to be able to acquire an image, be able to bring it in using their 3D sensors, and then be able to apply the correct tools on it, we're going to be covering once the software, this version of the software launches. As it comes online, we will make an evaluation on if it's going to be classroom-based where we bring everybody in, or is it something that could be remote-based. Because of the nature of the LMI, of getting the exposure right and actually working with the hardware, it would be harder to do as a full webinar based, but we're going to evaluate that once we get the software released and we complete our training part of the program. So stay tuned to our website for updates for classes and webinars. There's also multiple videos on LMI's YouTube channel that you can be able to access that include some step-by-step instructions on some of the different commands that you could go ahead and reference today.
Yes, this is definitely a little more technical than we normally do, but we wanted to show the LMI inner workings and that it's fairly simple. There are some knowledge points that you need to have, but again, that's what ACS is here for. We evaluate and test projects before we actually move forward with projects, and that's part of the idea of showing some of the capabilities that are coming. Again, hopefully within a month or two, this is out of beta and into a working version of software, but it's still available and it still works if you are okay with running a beta software. So this is a sample job that I built for that actual picking place I showed at the start. It's not much more programming, but I've done a GoCater Connect. I've initialized a count variable. That's just for me having these two random point generators. So if the count's 1, it goes here. If the count's 0, it goes there. I open my gripper at the start. That's just good programming practice so you don't crash into things. And then I have my scan height. I could rename that. So that's just the scan height for the program. Of course, in an actual working program, you probably have another move too. That would be like your home or starting point. But there's a scan height. And again, I selected that book specific to the 2330 sensor because it has a working distance and field of view that has to be accounted for. But then you just tell the GoCater to scan. You tell it to bring that coordinate stream over. I go to a safe approach point so I don't run into my part. I did add a little bit of Z. My TCP wasn't quite good enough, so I had to get a little extra Z height to get down to my part. I drove to the variable position. I grab the part. I come out to a safe position. And then just as a random point generator, this if statement says, if my count's 0, go to this 1 position. This could be called good part. And this one down here could be called bad part, technically. And then, of course, in each position, I drop the part off and then repeat the program. Oh, of course, a safe approach too, so I don't run into the part one more time. And then I'm going to flop back over and let you guys watch that program run for a second, and then we'll finish up and take any questions.
All right, while that is running, we did have a question come in from the group. Are we able to scan and find multiple candidates? So if you had more than one part in the field of view, would we be able to scan it and bring coordinates in for multiple items?
Yes, you can. That just takes the programming in the LMI to surmise, if you're getting 2 parts, which is the preferred part to get by your numerical grade or however you're trying to just make that decision. But you can scan multiple parts, yes. You might have to rebuild your tools, repeat them or something, but it's possible.
Okay. All right. Here's another question coming in. When doing an inspection, a measurement, feature, etc., how does the LMI communicate that it is a bad part or failed inspection? Does it send a Boolean back to the robot or a specified pass-fail bit?
It can do. It's up to how you build your communication, whether it be a simple signal for a monitor, like let me do this real quick. I mean, maybe you tie in your LMI programming, tie in a pass-fail value, and then just maybe send a simple input signal to say this was the good part and bad part, and have that monitored within your program tree. Or you could send over Ethernet in the, come back again. You could also, build something that sends out, build another tool that, the tool would be your inspection tool. And then according to the value, if it's pass or fail, because you do have min and max, you could just output that data over Ethernet as well. It would be another checkbox here to send that data over to the robot. And of course, then, do you want a full number? Because you could send a number over if you wanted to, or you could send over just a 0-1 that it's the pass fail. So that's it. I didn't build that, so I'm having a hard time explaining it just real fast. But yes, you can do that, and you can send over a string. That's not a problem.
Not a string, but you're talking about just a basic single bit that you can bring over as a true false. It either passes or fails.
Yes.
All right. I don't see any more questions right now. We're going to give it a couple minutes yet. So if someone does have a question they would like to pose to the group, please feel free to either put it in the chat window, or even for right now, you can unmute and ask if you would like to do it separate from the chat room. We can open that up for questions at this point.
Again, this is a very simple program. We just wanted to get you guys in some knowledge of some things that are coming out. This is still beta, but it's very powerful, and it helps tremendously with the LMI cap that's been built here to take out some of the calibration steps and the communication steps. So it's a really nice feature. It's free. It's not something you have to pay for. You get it with your equipment whenever it comes.
I thought I heard the start of a question. Does anyone have one? Okay. Well, Max, thank you for your time this morning. Thank you for putting this together and doing the setup for it. Oh, one more thing.
Always like to show this at the end. If you guys want to drop a line to us, info@ACS is always available. We evaluate everything, but that's a great way to get in contact with us if you have any questions.
Absolutely. So if anyone out there does think of another question, they have parts they would like to send for us to be able to test, and we will be happy to get back with you. So you can email us at info@acs-ga.com. It will, as Max said, and we can test that, we can video it, we can do web conference, or respond back to you in person once we get past this crisis. But I'd like to thank Max for putting this together and doing the research with it. I'd also like to thank everyone for attending. And just as a reminder, this has been recorded and will be on our YouTube channel. So please check it out and subscribe. And if there's someone else that could benefit from going through this step-by-step tutorial, please refer them to the channel and rewatch. So thank y'all for attending and have a great day.
Have a great day. Thanks for coming.